Hello class, how are you doing? Today I'm going to talk about gradient and the level curve. Let's talk about level curve. But prior to talk about level curve, I don't know how many of you know what the plane curve or space curves are. Plane curve, when you have two functions, and that is a function of t, such as t squared plus 3t, and you have another function of t that called the x quantity, and that's called the y quantity, means x and y both are depend on t. This is called parametric function, which x and y both on another parameter called t. If I take t as an independent value, then determine the x and a y according to the t value. Like if t becomes 0, x is 0, y is 0. I'm sorry, when t is 0, x is 0, but y is 1. And when the t is 1, x is 4, but y is 3. When the t is 2, x is 4 plus 6. 4 plus 6 is 10. And when x is 2, let me see, 2 squared is 4, 3 times 2 is 6, is 10. 2 times 2 is 4, plus 4 plus 1 is 5. If I go to my xy plane, when x is 0, y is 1. When x is 4, y is 3. When it's 10, is 5. Maybe it give me something, a curve like that. The combination of these two equations plus the graph, which also have orientation, and it has a starting point and an ending point. The starting point is t equal to 0, the ending point t is equal to 2. The combination of these three called plane curve. But if I make it a 3 variable of x, y, and a z, and add a z quantity as a function of t, that's called a space curve. Okay, at least we have some idea about plane curve and a space curve. But there are in many occasions that you have a function of 3 variables, maybe such as 4x minus y squared. Here, there is a quantity that depends on x and a y. And that quantity, I'm going to call it a z. And I'm going to ask you, what happens if the y become a constant? The trace in a z x-axis is going to become a line with a slope of 4. If x become a constant, in a zy plane, the graph is going to be a parabola. If z become a constant, in an xy plane, the graph is going to be a parabola, either faces open face to right or left. And you're asked to graph this, sometimes without the technology, this is not easy to graph. But you're going to say, okay, I can graph these when z is 0. Okay. Therefore, in here, you said x equal to negative 1/4 of y squared. And that's not hard to graph. Therefore, in here, your z is 0. And when y is 0, x is 0. But what happens if x become 2? When y become 2, right here. 2 squared is 4. 4 over 4 is 1. X is negative 1. But what happens if y become negative 2? Negative 2 squared is 4. 4 over 4. And x is going to become a negative 1 again too. Therefore, you see my graph is going to become a parabola and it faces down in a x, y plane. And you have to hold it like, let me see. You have to hold it like this, and that's become your, remember that's your z-axis. I'm not worried about it. This is your y. This is your x, and this is your y. This is called a plane curve. A plane curve means what they call it plane curve. The level curve. Why they call it level curve? Because you are doing in a ground level. What happens if z become equal to 1? You go 1 feet above the ground, and you're gonna graph your y-axis and x-axis and the z-axis, and you're gonna do another plane curve. But when you put z equal to 1, that would become 1 equal to 4x minus y squared. You bring the y squared to other side, it becomes 4x minus 1. Or here I should have y squared plus 1. I shouldn't have moved the 1 to other side. And x is divided by 4. 1/4 plus 1/4 of y squared. See, that graph is still that graph, except shifted in the y 1/4 up. Therefore, it's the same thing, you just shifting it up 1 unit. And that would become the level curve at z equal to 1. And you can do the same thing at z equal to 2. Therefore, you know at every level curve, z is constant. Here at that level, z is constant. And z here is 1, here z is 0. Therefore, if z is a function of x and a y, but remember I'm talking about a level curve. Level curve is nothing except the plane curve, means we have to parameterize the plane curve, parameterize the curve. Means x is going to be a function of t and y is going to be a function of t. Somehow I have to parameterize that curve. Therefore, if I want to take the partial derivative of the z, derivative of a z respect to t, I have to use ordinary because that's only one variable, is partial derivative of z respect to x, because here you have two paths, you have to use partial. Therefore, from t to z, you're going to have two paths right here. One go through x, one go through y. This is dx dt. And if somebody say, why here you use partial, here you use ordinary, because that's a single variable and this one is a multivariate. Plus partial derivative of z respect to y, dy dt, because this change of z on a plane curve, z is constant, the change of z is 0. Z doesn't change. Z is on the plane, on the level curve, z is either 0, z is either 1, or z is either 2. Therefore, the change of z respect to time is 0. Means if you're traveling on this path, And this is, look at the 4 feet above the ground. Therefore, the change of z right here is the same. It's only x and y changes. Therefore, this is partial derivative of z respect to x dx dt plus partial derivative of z respect to y dy dt. Therefore, here what you see is sum of two product, and sum of two product means the dot product of two vector. And when the dot product is 0, these two vectors are orthogonal. This is nothing except the gradient of the function. This is nothing, a vector u in this case is r prime. But you know, if you have a level curve and this is your r prime, this is your gradient. And we talked about that every time the angle between the directional vector and the gradient is 90 degrees, then the directional derivative is going to be 0. Remember, we had directional derivative of the function of x and y was gradient dot with a unit vector. And if the directional derivative becomes 0, the rate of change, the dot product is 0, means these two are orthogonal. Therefore, if the directional vector and the gradient are orthogonal, therefore the directional derivative, the rate of change or directional derivative in this one, in this direction is 0. Means there is no fire burning here in this direction. And or there is no water passing, means the rate of change of water is increases or decreases. The water goes steady at the same speed, or fire is burning at the same speed. It does not have the slope or rate of change. It is constant. Then from today you have to know your gradient always normal to the level curve, because on the level curve the z is constant, the derivative of a constant is 0. The chain rules is the sum of two product. One is the partial derivative, which is called gradient. The other one is r prime, and that equal to 0. From today you have to know, in no matter what I have as a level curve, the gradient of the function always going to be normal to the level curve. Remember, that's the point. That's nothing except your r prime right here. Therefore, if I ask at some given time that I have a function of x and a y, and I said this is x squared minus 3xy plus y cubed. At the time, when x is 1 and the y is 2, what is the directional derivative? I said directional derivative at the point of 1 and 2. What direction? There are infinitely many directions. You give me the direction, then I find the derivative and dot it with the unit vector with the direction you give me, and I find the directional derivative. But I'm going to say, well, there are infinitely many directions. Give me the directional derivative which the rate of change is the fastest. I said, oh, fastest means your unit vector, if it's cosine theta, sine theta, these are all proper fractions, and the value of sine and cosine is always between 1 and a -1. And if you multiply any number, it doesn't matter if it's a proper or if it's an improper, multiply by proper, you decrease the value. then what should I do to not decrease the value? Don't multiply by proper and just use the gradient, and that gradient is nothing except 2x minus a 3y, and that's become negative 3x respect to y plus 3y squared. And if you replace 1 and a 2 for x and y, that provides you with a vector, which that vector gives you the direction that something is changing the fastest. I don't know if it's money in the bank growing. I don't know if it's a fire in the jungle which is burning the jungle. I don't know if it's a water you go through the bed of the river is going the fastest at that direction. I don't know what it is, but all I know, when x is 1 and 2, you have 2 minus a 6, and you have negative 3 times 1 plus 3 times 4, and that gives you a negative 4, and negative 3 plus 12 is a 9. That gives you the direction that something is changing the fastest. And I said, well, I know you gave me the direction, but what is the derivative? What is the rate of change in that direction? The magnitude of that vector called directional derivative. And what is the directional derivative of that function at point 1 and 2? It is square root of 16 plus 81. This is how fast something is changing. Or if this one was a negative, how slowest. Therefore, if this one is the fastest, I bet you this is the slowest. And this is a relationship between the gradient and the level curve, that the gradient is always normal to the level curve. But somebody said, okay, but I have a function of x and a y and a z, and this is x squared, y, and a z, and in here, if I make the w a constant, I no longer have a level curve. I have 3 variables that I have to parameterize it. I said this is called level surface. And what do I know about the gradient? The gradient is normal to the level surface. I don't know at the z equal to 1. Let me give you an example. Let's say allergy is killing me. The w of xyz is x squared plus y squared plus z squared. At the w equal to 0, what do you have? You have a point. W equal to 1, what do you have? That's 4 dimension. You go 1 unit above the space and you have a sphere with a radius of 1. What happened at the w equal to 4? You go 4 unit up in the w axis. At that level, you have a surface with a radius of 2. Therefore, that is a level surface. Maybe that level surface is 4 unit above. If this is 0, 0, 0, 0, remember I have 4 dimension, 1, 2, 3, 4, and I'm going to have 3 axes right here. Remember, this is a W. All 4 of them are orthogonal to each other. That's X, Y, and a Z. You have a sphere 4 unit above. And what is the gradient of a W? 2x, 2y, 2z. Therefore, at any order pair, that gradient is normal to a level surface. These are surface on top of surface. The w go up or down. That is a relationship between the gradient and level curve and the gradient and level surface. Why do we have to know that? Because eventually you have to write equation of a normal line and equation of a tangent plane. For a normal line, you need a vector parallel to the line. For a tangent plane, you need a vector normal to the tangent. And you can use the gradient to write the normal equation of a normal line on a tangent plane. Thank you.